Good evening, everyone. I extend a warm welcome to all at the fifth session of International Virtual Conference on Chemical Sciences 2022. I find my immense pleasure in introducing our chief guest, Dr. A.K. Prasannan, Assistant Professor, Department of Material Science and Engineering, National Taiwan University of Science and Technology, Taiwan. Prasannan is a scientist in the field of polymer science and material science, and he is especially focusing his research on the fabrication of polymer-based nanocomposites and hydrates with various nanomaterials. He published around 50 research articles in various research fields, with concerning to prepare membrane fabrications, polymeric nanomaterials, carbon materials, environmental science, energy science, and biomedical applications. He have a postdoctoral research fellow in the National Taiwan University of Science and Technology from 2011 to 2020 in various departments. He is also a guest editor in a peer-reviewed journal. It's a special issue of functional features of advanced polymer nanocomposites. He's a reviewer in many of the international peer-reviewed journals, listed below a few: International Journal of Hydrogen Energy, Journal of Cleaner Production, Material Chemistry and Physics, Colloid and Polymer Science, Journal of Polymer Science, Reactive and Functional Polymers, Applied Surface Sciences, Sensors and Actuators, Journal of Membrane Science, Journal of Alloys and Compounds, Separation and Purification of Technology. He have excellent leadership qualities. Listed below are the few. He is a team leader of Environmental Safety Officer from 2006 to 2007 at Asian Paints, Chennai, and a co-founder of Organization of Indian Cultural Association in National Taiwan University of Science and Technology, the year 2007. And he is the organizer of Indian Cultural Committee in Taiwan and General Secretary of Taiwan Tamil Sangam in Taiwan, and International Research Coordinator in NTUST. We find very happy to welcome you here, sir. We are here to hear your valuable speech. Thank you, sir.
Thank you so much, Dr. Divya, for your deep introduction about me. Thank you so much for your wonderful invitation for me to present this kind of initial conference in your university and in your college. I'm glad to be here. Should I turn on my video or no need video? Which one you are preferring?
Yes, sir. Once started presenting your presentation, you can.
Do you want a video or no need video? Just slide okay, right?
Okay, sir.
Okay. Okay. Actually, today I would like to discuss something about bio-inspired nanomaterials. You know, like a bio-inspired nanomaterial is a wide range of applications over there. That's why it's really tough topic to discuss too much distance. That's why just I wanted to focus only few things. Just a minute, let me change my. Just a few things about wettability, surface wettability. And the surface wettability, I want to discuss something about the fundamental view. Do not discuss too much discussion on the deep way. Just a fundamental view about the surface wettability, what will be that in the view of bio-inspired aspect. The wettability, we can use the variable applications, as everybody knows, is I'm just a little bit focused about the liquid separations, because since we are working under membrane. By the way, you have done that very good and deep discussion about my introduction. That's why I don't want to discuss about me and where I'm working. This is a slide. First slide itself, we can show everything there. Directly, I will go to my content. The contents goes to the little talk about the bio-inspiration. And from the bio-inspirations, how we can use the wettability like a super hydrophobic and super hydrophilic. We can speak about that is called like wettabilities, right? These hydrophilic or hydrophobic, how we are going to be apply the variable applications. And what are the technique we can use the categorize for those kind of surfaces. And the fabrication process also we are going to be discussed about this sometimes. Then from these kind of information, I try to introduce some of my articles recently were published from the wettability materials, the bio-inspired based wettability materials. That's why these are the some overall outlook what we are going to be listen today. That's what most of the times my talk goes with the bio-inspired. How we are going to be inspired with the bio. This is what we are going to be speak few slides. The inspiration, of course, we know inspiration is almost we have to admire something and we have to astonish something and we have to follow some them to produce or follow, or we have to establish some our own things. This is called like a inspiration, right? We are everyone know. From the inspirations, we have to take as a bio as a inspirations to produce science and technology to be the advanced research. This is that's why the recently the many people are trying to focus to prepare the bio inspiration based materials. Actually, the bio inspiration we can categorize a few things. For example, it can be like a bio mimicry. The biomimicry means just we have to use the function or principles like the nature. The next one we can use like a biomorphism. The biomorphism means seems to be same, look like the same. The look like the same with what are the we are getting from the nature. This is called like a biomorphism. Then one more we can call like a bioutilizations. The bioutilization, of course, most of us we are thinking bio-inspiration means bioutilization only, because as of now, the most of the research people are trying to use the biomaterials, extracted materials. They try to use some kind of nanomaterials as a medium, as a template to produce it. That's what we are going to be as we are considered so far like a bio-inspirations. But really, the bio-inspirations is like a biomimicry or biomorphism. These are the most of the more or less more advanced field in the bio-inspirations. That's why we are considering nature as a mentor, or we can consider nature as a model, or we have to use the nature as a production material. These are the overall view for the bio-inspirations. For the bio-inspiration, where it will be started, we have to consider about the starting origin. The starting origin, of course, everyone, we know the story about the apple story. The apple, whenever the Newton was lying on the apple tree, the apple was fall down, then he was thinking, okay, why he fall, something like that. We know this kind of childhood story, right? The same story only induced him, like Newton, to make the gravity law to establish the sun and other planet, how it should be around us. The similar manner, the Maxwell and the Faraday, of course, the well-known name for us, these are the people's responsibility for the electromagnetism. Through the electromagnetism, how they find out from the magnetism and the current, electrical current, whenever they're thinking, they can found this kind of electromagnetism properties there. So that means the current science where we are going to means we have to somehow, somewhere, we are follow the nature, or we are learning from the nature is more attention. That's why I just kept keeping like here, the question mark. The current object of the attention is the chemistry, where is going? The going is towards the some bio-inspired or bio-mimicry or bio something like just to follow the bio as a guidance, as a mentor. So if whatever things we just imitate the bio, our research could be the similarity with the same property with the nature. This is what we are going to be use it. That's why there are many invention. Of course, in our life, we every day to life we are seeing the many inventions from the imitate the biotin. For example, like aircraft or wings, aircraft wings. This, of course, we know these are the come from the birds wings as well as the shark fish. These are the way we are so far we are using the transfer. So there is no matter about the what kind of design we are using, just to follow from the nature and imitate the nature to make the successful design and successful scientific invention for us. This is what like a biomimicry or bio-inspiration for our day-to-day life and going on that. So that's why there are many bio-inspired material they can use as a natural, like a, for example, like a mentor. For example, this one. Hope everyone home we can see about Chico. The Chico have anybody, any times did you think about why the Chico will be stay without anything fall in the ceiling, our home? Because whenever we think about things, then only we can understand, oh, okay, the bio-inspired materials, the biomimicry material, how is this important? Because if it is that much weight made object can be held on the wall without any support means that must be some uniqueness in their Chico hand. The Chico hand will be, whenever the scientists see the Chico hand, they can try to produce some kind of shoe, the gripless shoes. This kind of shoes, whenever we are going to be trekking, they will not be slip out. That time we are going to be like kind of shoes. This kind of approach we are learning from the Chico and their using our science, just imitate the nature. That's it. For similar way, the big object I'm telling, this slide will be focused the big object, not like a micro scale. This is everything like macro scale based materials. For example, like whenever they see the lotus, they build up the Sydney things, and from the cucumber they found some other things. Some the nest they're using something. There are many objective we are learning from the nature, and we build the similar property or similar appearance or similar functions. These are the some more evidence, just learning. That's it. The keep on. I'm trying. Recently, my research tried to focus towards nature, because towards nature means we try to prevent our earth without any other problems. Whenever we are, since we are the chemistry background, we are how to use the many chemicals instead of the natural materials. The chemicals are both the hygienic for us, not only us, in the even earth. That's why just I'm thinking to consider bio-inspired or biomimicry material will be one of the alternative material to prevent the earth or to save the earth. That's what one of the section we are going to be used that word. So whenever we see the big object, that's no problem. That is not a big issue. That's not a big uniqueness. Whenever you see the focus, their design, their architecture, their morphology, and their property should be admirable one and astonished one. For example, this is like a among here, there are everything is astonished, but here we can see the bee eyes. When we focus the bee eyes, there is uniform array will be going aligned in the surface. Based on the align, we are going to be using some semiconductor device, this similar pattern. Whenever we prepare a similar pattern, the efficiency of the semiconductor will be higher. Then if you look about the sunflower, the sunflower pattern is also the central pattern is an admirable one, is astonishing one, is no one can be produced except than the nature. The similar one, whenever we are going to be produced, the sunflower is a kind of the biggest first ever solar cell applications. Because of the array, the solar light will be observed and reflect into the environment. Then automatically it can be used as a naturally available solar cell system. This is the first solar system from the sunlight because of this kind of pattern appearing. Then if you consider about a spider silk, of course, this is everyone we say it's a spider net. We are speaking about a spider net, but scientists can speak this is a spider proteins or spider like a sericin, like this material. They're just using the fibrin materials, something like these are fully made by the amino acids. There are 36 amino acids are coming together is make like a natural fibers, very strongest fiber in the world. So far, the people are thinking, even this is a synthetic fiber, we are thinking about aramide. There is a polyamide based fiber is the most strongest so far people are thinking. But in upcoming year, we are consider that many people are consider the spider net can be have the highest mechanical property than equal to the aramide things. The thing is how we have to establish the similar manner. The same mechanical properties or same chemical compositions. These are the things we have to learn from that. That's why the bio-inspired materials, not only the looking outside, we have to look about their properties and their functionality towards the applications. This is the most important for us to use it. Okay, we are last 10 to 15 minutes, we are speaking about inspire. Who inspired with bio? First of all, from the nature. This is from the gentleman from the America. He is a biophysics guy. He only inspired first time when he looked the squid. Whenever he understand about a squid, knows how the squid, whenever you see the squid, of course, many of us we see the squid, they can walk without any struggling. They can, their legs can be go 360 degree. Any direction can be movable. That much quantity, that much more flexibility will be that. Because of that one, the main functionality come from the nerves of the squid. When he looked the squid, then he want to find, okay, this is some astonished materials, something going that, why not we can produce something like that. He tried to establish from some polymer materials. From that, he want to produce. So this is the first person who established like inspired from the nature. And there are many, of course, there are too much examples so far we are using. The approach, as I mentioned, just we have to think about design. What kind of design we need, and those kind of design will be exist in the biology. If yes, so similar biology system, we have to again design the same way. This is what we are going to be approach. We are going to be use them, design the biomimicry or bio-inspired material. These are some example only. I don't want to waste our time to be explain many of things. Of course, whenever you see the picture, we good understand how many material we are inspired from the nature and we established into the recent technology peoples. So this is not a problem. Now we have to think about, as I mentioned, like a biomorphism. What are the things we are exist in the biological system? The same things we have to understand. What are the patterns they have? What are the morphology they have? If what are the system arrangement will be that. The similar manner we can have the possibility to produce in the laboratory means. This is called like a bio. That's why we just to understand that, for example, like a lotus leaf. Whenever we speak about a lotus leaf, when many people say we see that lotus leaf just like beautiful things. But later on, in the super hydrophobic surface, lotus leaf is one of the major role to make the one separate principle. Maybe later on slide we can going to be talk about a lotus effect. That's lotus effect different. Okay, anyway. Because of the lotus effect, the people want to know what are the morphology in the leaf. We want to understand, because every super hydrophobic property means we must be have some unique property. The unique property, if we understand the surface, the atom arrangement or molecular arrangement, then based on the molecular arrangement or atom arrangement, we can establish our own laboratory made materials. That's what this slide we are going to be using small, whatever we see the regular way, the all SEM image. This one like a real one, the real one SEM image we have to see, look at this means it's almost like a nanomaterial. We can see even the particles are aggregated, particles are arranged within submicrometers to combination together, and he established the uniform way. This kind of things, these are the roughness, the particles are responsibility to the superhydrophobic surface. The similar manner, whenever we see the butterfly wings, the butterfly wings is one of the great optics materials. So far, we are thinking that this is a naturally available optics wings, optical materials, it come from their wings. Because of that, the different color pattern. Whenever you see the butterfly, there are many color patterns. The every color pattern, every direction, it can be changing. That means the optoelectronic materials, can be have the big role, such a array. So that means we have to understand what kind of alignment, what kind of arrangement of atom or the molecule will be exist in the rings. That means just want to means the SEM image clearly mentioned the layered arrangement of the molecules is responsible to reflect the light from the sunlight. Then every light can be produced, depends upon their orientation, depends upon the alignment, the color will be reflecting. Based on the color reflecting, we could see the many colors from the butterfly wings. Similarly, there are many aspects. For example, like a dragonfly and a water spider. Because water spider, whenever you see the beautiful of water spider can be walk in the water. So that it can be walk. That's what I think the only one, whenever he walking, the water cannot be observed their hand. And that it cannot be shrinked or it cannot be destroyed by the water. That means he can be walkable very easy. That means his leg must have the superhydrophobic property with different manner. That's why we have to understand the morphology. When we understand the morphology will be the very thinner way, then it can be easy to reflect the water molecules. Of course, this part he can walk in. And like a rose, same story of lotus leaf. When you see the rose after raining, the rose water droplets sit on the rose flower. It look like very beautiful, right? Everyone we might be enjoyed in the childhood. Even now also we are enjoying. Whenever the rainy, after raining, the rose he capturing small water dropped on the rose petal. So the capturing water is not beautiful, is also having the science about the water capturing property. The water capturing property is come from the surface molecular arrangement. When we see the surface molecular arrangement the uniform way with the roughness, those roughness is responsibility for both either water acceptance and water rejection also. Whenever water rejectant is more, the water droplet will be more beautiful. Whenever water is absorbed more, the water cannot be seeable. So this is a similar story about like the water lotus. And of course, one more like a peacock. There are many applications. Whenever we are seeing the outside, it's like beautiful. Whenever we see inside as a chemist guy, as a chemist point of view, everything is a miracle. The nature is a God, as we know. So, okay, we have to consider already nature produces something. Similar manner, we have to produce something. What kind of things we have to use it? That means when we are going to be inspire something, of course, we have to inspire first of all. Then only we have the chance to produce such things. There are two things we are going to be approaches. The approach is one is a problem based, one is a solution based. So problem based inspiring system, we have to understand what are the problem we have. For example, if I want to use something like for example, like whenever we use the kidney purification system, like a dialysis bag, the dialysis bag, whenever we produce a dialysis bag, the blood must not contaminate with the bag. That means your material must be hydrophobic. Same time, the blood contaminated will be exist in many, like proteins or platelet or some other ions should not be attached to your material. That means we have to understand what are the problem we have right now. Based on the problem, we have to understand the reframing the problem. Then we have to find the similar aspect of material from the nature or biological system. Then based on the biological system, we have to understand their solution. Of course, the nature have always a solution. That here the solution, based on the solution, we have to take out the extraction and we have to use as a particular application. This is like a problem-based one. Solution-based, first we have decided what kind of material we have. For example, like lotus leaf. The lotus leaf, I want to make like a kind of lotus leaf like material, means already I decided what I needed. Then based on that, everything we have to refine and extract, and again we have to go with the problem, incorporate problem, and we have to use the problem. Then finally applications going to be used. These are the two approaches we have to follow when we are considering about inspiring the design by a problem based one or solution based one. So the problem based or solution based, just to use the biology people and engineering, whenever it combines together, then automatically we have to use the desired application to produce the inspired materials. Okay, the inspired materials, most of times we are considered about the superstructure only, because so far we see there are many superstructure. For example, like a rose, fertilize, we showed on the slides, like a lotus leaf. Other things also we saw it. Everything have the superstructure will be existed. The superstructure is kind of complexity, because this is not simply one kind of structure will be exist. This kind of complexity will be there. This kind of complexity structure can be applicable with variable applications. The variable applications means, first of all, we speak about like a superhydrophobicity, because superhydrophobicity is one of the recently developing topics. Similarly, superhydrophobicity. Superhydrophobicity is different from the superhydrophilicity, because of course, if you are not really follow the what is a superhydrophobicity, what is superhydrophilicity, we will go to next slide. We can speak about those things, because this too is considered as a wettable property of the materials. So any of your recent kind of membrane applications, whenever we are using like water purification system or blood purification system, or whenever we are using like a medical diagnosis system, everywhere the superhydrophobicity or superhydrophobicity is a dominant role to decide your material performance. That's why this nowadays a most interesting topic in the bio-inspired based materials. Okay, the next one we can consider about few things is called like a self-cleaning. The self-cleaning is, that means we don't want to wash it or we don't want cleaning. Is nowadays the many of the cloth and many of the textile industry, they try to focus the wash without wash any materials, means this better like this way. The people are thinking to use like a self-cleaning material. That means whenever we are using any kind of dust or dirt material, when approach your cloth, it automatically removed because of their super hydrophobicity. Because the super hydrophobicity will not allow the dirt will be enter in your materials when treated with water. So that's why the super cleaning is another recent approach developing applications via superstructure. Okay, then after that we have to consider about the directional addition. This is one more like a hard topic we can speak about in the biological peoples. This is a kind of hard topics. Usually the blood purification system. Maybe we will take later, no problem. Then next one we can consider about the water collections and the anti-reflections. These are some other applications we have to consider. There are many applications around the bio-inspired based materials. The bio-inspired based materials generally come from the superstructure as I discussed it. So small short note about hydrophobicity. I just want to know everyone we know what is hydrophobic, what is hydrophilic, but we have to incorporate here is a super. The super means, of course, this is like a more, that's it. The super, whenever we are coming, means the hydrophobicity or hydrophobicity, either way, no problem. Either both place we can use a super. This means whatever we have defined, that define will be more and more. That's it. So whenever the water molecules enter into your surface, the water cannot be attached or water cannot be received by the surface. That means hydrophobic. We know the same hydrophobic, if it is attached or reflected too much, that is called a super hydrophobic. That's it. The first example super hydrophobic means is like a lotus leaf only. So whenever you see the lotus leaf, because I don't know how many of you played in the small age. I also played. Just take the lotus leaf, put one drop of water, and I roll on the surface of the water leaf. That is playing. When I was a kid, I was playing. Now I could understand what is the reason water molecule, why it cannot be stay, why it can be perfect spherical. So if you are the same water drop in the earth or some other object, the object will be consumed all water, the water will be disappear or water will be flattened. But whenever we use the lotus leaf, the water droplet becomes droplet, the full droplet. The same thing we can see in the grass also. There are many grass. Whenever, for example, there are many argumbil, something like that. We have whenever we go to the farm or outside, there grass or like a rice plant also. After rainy finish, the water will be stacked in particular row. The particular row only we can speak about the directional additions. The similar manner, the all hydrophobicity is come from of course, the chemical compositions. Apart from the chemical composition, the roughness is the most important into that. The same water molecules here, the SEM image, when the water droplets is enter into the lotus leaf surface. How the roughness will be reject your water droplet. This is what the people are trying to find out. Then accordingly they find it. So based on these things, we can keep the other name is called like a wettability. The wettability means when we add some drop of water, the water must be how fast he is making wet or how fast he rejected by the surface. This is called wettability. So whenever when drop the water, your droplets is almost spreaded. For example, here, this is called like a super hydrophilic nature. The superhydrophilic nature means the water droplet under your surface does not have the contact angle. The how water molecules, water drop is contacting the surface. This called, we can use like a contact angle measurement. We can speak at this less than 5 or less than, sometimes some people are thinking about less than 20 is like a hydrophilic nature. Some people are thinking less than 30. It depends upon the who writing, because whenever I'm writing the manuscript, I can always keep the less than 20 means this is a super hydrophilic. But some people are thinking less than 10. Some people are thinking like 5. This depends upon their view. Okay, fine. The same if it is a little bit around 90 degree, the angle should be in the surface, and water drop if 90 degrees like a hydrophilic. Same thing. In between means is like a hydrophobic, like a 190 to 120 is like a hydrophobic. Then most of the time we don't want to speak about the ultra hydrophobic. Directly we can speak about super hydrophobic, because the moderate hydrophobic is not that much applicable in the many places, but super hydrophobic is the most applicable in the variable applications. So when the droplet meeting with the surface, they can decide your material can be the wettability or super hydrophobicity. These are the main things. Of course, you can see here the clear image. The surface and water droplet should not have any contact. That means your contact angle more than 150 degree. That is called like a super hydrophobic. When your contact angle is less than 10 or less than 20, it's like a super hydrophilic. This is what we are using. So most of our material, natural material, some other, whatever we see is in between, like a balance. Hydrophilic material, hydrophobic material, always combine together and it will be there. That's why it is like kind of phobic materials coming. So this wettability or phobicity is depends upon their many factors. The many factors, most of times we can use like a how the surface energy, every material have the surface, they have the energy. That surface energy will have them responsibility to produce the materials. So if it is, whenever you use the low surface energy material, means that always having the hydrophobic materials. Whenever having the high surface energy, the surface energy generally defined by the chemical functionality. What are the chemical functional groups there? That chemical functional groups can be desired. Your surface energy will be high or low. If anything like a heteroatoms, those heteroatoms always having the high surface energy, because every application will be desired by the high surface energy. Whenever you have the high surface energy, the application, the performance will be higher. That's why nowadays nanomaterial having the more popular. Everyone say nano. Why? We need to understand what is the reason behind the nanomaterial become the hyper intentions. The hyper intentions maximum come from the high surface energy. If anything smaller size, that automatically have the high surface energy. The high surface energy you can retain or you can obtain when we incorporate heteroatomic atoms in your materials. Okay, not only that one. We have to consider many other factors. One more factor is like roughness, how much your material have the roughness, and how your material have the porosity. Porosity means how much the pore will be exist, and the surface tension of your materials. This surface tension, how it will be interactive with the surface energy. This is a both are balanced, should be equal. Okay, the surface energy is desired by the surface chemistry. The surface chemistry, as I mentioned, whether you have the heteroatoms or just carbon or just like alkyne groups, everything is depends upon your surface groups. Then the surface functional groups can be applicable. How about their morphology? The morphology, roughness, porosity, and surface energy, and surface chemistry. These all are most important for the wettability property. Okay, whenever this is what I mentioned, the wettability will be desired by the heteroatom already mentioned. So here you can see the hydrophilic nature, the most of the hydrophilic natures, it come from the variable, the heteroatom. Whenever you incorporate your materials, then automatically it will be more hydrophilic nature. Whenever you are using non-polar materials, if anything no polar, that means the automatically it can be give the less wettability, like a alkaline group or something aromatic groups or fluoro groups or silicon groups or silaxine groups. Everything can be responsible for the low surface energy. That means it automatically giving the super hydrophobic nature to produce it. These are some example I gave. So now I need to explain about what is the difference. Whenever we see the like a rice plant or grass, you can see there is water drop is around the surface. Okay, or whenever you see some plant leaf, there is water. So some leaf can be attached to water very uniformly. Some leaf cannot be attached. There is a spherical water drop will be existing. The spherical water drop, they use like a different aspect, the phenomena. The contact angle phenomena we can use like a Wentzel and a Casio form. The Wentzel film means that your water droplet and your surface must not have any air. That means there is no any interference. There is no any interference. The water molecules or water droplets is easily adherent and it is easily attached on the surfaces. That always give the water droplets spread in the materials. When, for example, whenever you take the lotus leaf, the water droplet is like a spherical, perfect spherical shape. The perfect means between the surface, between the water droplet, they have some air lagging. The air packet will be reflect your materials. That means the roughness will be responsibility to remove water molecules from the substrate. These are the same things. The roughness will be attached water molecule to the surface. These are two different approaches. We are using the hydrophilic and super hydrophobic, both way. I need to consider about the self-cleaning, one more topic. The self-cleaning, already mentioned, the super hydrophobic material only having the self-cleaning ability. If you whenever you use the hydrophilic nature, if for example, this is a dust, the small portion is a dust. Whenever you are using the hydrophilic material, your water droplet is always spread on the surfaces. When you spread the surface, there is no any possibility to capture your dust molecules. But whenever we are using to the super hydrophobic material, the water molecule does not spread it on the surface. He will be roll on the surface. Whenever he roll on the surface, he capture or he attached a water soluble all dust molecule along with your water molecules. This is what we are using as a name. The concept is called like a self-cleaning ability or self-cleaning behavior. Okay, the self-cleaning behavior, whenever we see the materials, this kind of, whenever we found the water droplet, the droplet having the dust molecules or contaminated particles on the surface from the SEM image. So this other one, we have to consider about this already we know. Hydrophobic surface, what is a super hydrophobic, we know already. One more topic we have to understand means like it called a tilting plane method based dynamic contact angle. The dynamic contact angle is one of the good method to understand your material is good or self-cleaning behavior or not. Because when we use the tilt or just it is a surface, whenever you add some water droplet and you just tilt in a surface, the water molecules will be moving. Whenever he moving, we can use like a advancing contact angle and a receding contact angle, like this two concepts will be there. Based on them, the advanced contact angle should be more higher than receding contact angle, because receding contact angle will be leave the molecules and the water molecule will be easily go away. Whenever if we have this kind of calculations, if we found out, then we are usually identified the material can be the self-cleaning behavior or not. The similar manner we can use other one is called a volume change method. Just drop the water, again the water molecule, how fast he will be jump from the surface. This is called like a volume change method. These are either way we have to use to understand the self-cleaning behavior of the super hydrophobic behavior. So now we have to consider, okay, we always, there are many topics we speak about the super hydrophobicity, but at the same time we have to speak about super hydrophobic because they both are balanced in our life. Only super hydrophobic is not good at all. Excuse me, Divya, should I finish my talk within 1 hour or should I extend? Can I extend it?
No, sir, you can extend.
Sure, right?
Yes, sir.
No bother, right?
No, sir.
Okay, thank you. Because I don't think so I can finish it within for at least 30 minutes more from right
Okay,
now.
sir, no problem.
Okay, thank you. So whenever we speak about super hydrophobicity and super hydrophilicity, also most important for us to activate our many biological based applications. Because this is a super hydrophilicity is not really good for the biological applications because some way we have struggling on it. Because most of the biological material will be attached to hydrophobicity attachment, because there are many physical bonding. The physical interaction will be there. Hydrophilic is no problem, but hydrophobicity, hydrophobicity will be easily interact each other. Seems to be like equal to the van der Waals force. That means all biomolecule will be easily attached. That means there are limitation to use the biological application in the super hydrophobic materials. That's why we have to consider about this one. That whenever you see the interesting peoples, how many people are doing the research recently 2000 until 2017 the hydrophobicity and hydrophilicity. So that you can see the light blue color. The light blue color is almost like a super hydrophobic nature. Many people want to produce a super hydrophobic nature only. Then only they try to understand the limitations. Okay, hereafter we need to find out something like a super hydrophilic materials with bio-inspired. This is what we are going to. That's why there are very limited people only we are focusing. That's why now we are speaking about either super hydrophobic and super hydrophilic process. Anything, both will be that. That means these are some timeline, just keeping the timeline for both philic and phobic materials. So for what we people are follow from the bio-inspired, this is none of the more discussions. That's why no issue. So just now we speak about there are many surface morphology and roughness can be desired your materials like natural material. Already we understand it. But thing is, we have to understand the surface property, the surface, how the wettability, the contact angles are with whenever we observe the water molecules, how the contact angle will be there. Same thing, whatever we show the before slide, the same slide only I'm just keeping here. But the only thing is the same surface with their contact angles. For example, this is there many like a roughness will be there. This kind of small roughness, they're kind of connected with many molecules. This kind of things will be having the high wettability natures. You know, the same thing like whenever we see the bee feather, he can have the super hydrophobic, like hydrophobic nature. When we droplet in the water molecules, 126 angle will be there. Then some other butterfly, most of the butterflies almost like having the distinct particles, like a dense kind of particles will be exist. This kind of particle, the roughness will be induced for the higher contact angles. Same things. in the dragonfly, and this fruit and the layered structure. Ultimately, we have to understand the molecules, how he patterned in their surface. The similar pattern, if we supposed to be produced in our materials, we can fine tune whether you want hydrophilic nature or phobic nature. The similar pattern, because whenever you see, for example, similar pattern only we have the feather, both the ant and the butterfly, but only the distinct particles is missing. But here the roughness higher, here the roughness is lower, because the automatically will be there. That's why the roughness, how much is lowering, that might the wettability nature will be increasing, and your phobic nature will be increasing. This is a different. The atom arrangement is a responsibility to form it. That's the reason I just mentioned there are many approaches. There are many approaches, as I mentioned, like a lotus leaf, the spherical form. As I mentioned, like a rice leaf. There are different things. This is called, we can use it called the directional wetting property. Whenever you see the rice leaf, we found the all water molecules in the particular directions, not in the accumulated. The particular direction is only the responsible for the directional wetting. Then this kind of dumping battle, we can see their bottom of the stomach, they're always collecting some water for their family. When I don't know how many people you see this one. This is most of the times in the forest time we can find this kind of dumping battle. This collection property also responsibility to how the molecule will be used. Then pitcher plant, we know this kind of things. The heat can capture and he eat the many insect. This also will be responsible for the slippery surface. Whenever any insect will come in and he will be slip into their cage and he will be destroyed. These are the all property responsibility from the surface of materials. Okay, the surface, just we can go the deep discussions. Whenever we see about lotus leaf, the already mentioned the surface roughness is a responsibility to produce. So he is a lotus SEM image. The same thing, the people try to produce the similar manner with the carbon nanotubes. The carbon nanotube, whenever you use the carbon nanotube, they try to produce a similar materials as imitate of lotus leaf, and we can produce a high similarity of almost same contact angles that are received around 160. That means superhydrophobicity will be existed. The similar manner, when use the lotus rose petal, the rose petal also having the high roughness. The similar roughness, if you want to prepare, they have to use some kind of polystyrene based film. The polystyrene film, whenever they mix it with the silicon array, they have to produce the same similar property of rose petal. He want to use as a superhydrophobic materials. And one more things we have to consider about a directional wetting property. The directional wetting property is both rice leaf and butterfly. Both way they try to use like a polyparastyrene material. They just produce the polyparastyrene material. The similar pattern, what are they having the rice leaf? Both hydrophilic nature and hydrophobic nature, everything coming together and align in the surface, that can be used the similar manner with the butterfly wings also. In the directional wetting property, the same polymer they can produce as a nanoparticles and a pattern. This kind of pattern will be give the similar property of your butterfly wings. Last time we mentioned like a water collection. The water collections, the materials always using like the body of the petal. He have the both either hydrophilic nature and the hydrophobic nature. Whenever you have the hydrophobic nature, the water will become the spherical. Then combination of hydrophobic and hydrophilic he can consume the water molecule. For example, they have the hydrophilic nature, they attach the water molecules. Whenever they have the hydrophobic nature, he rejects the water molecule. That means all observed molecule, water molecule, become the collective manner. Whenever he become the collective manner, he automatically reduce the water as a particle, water as a bulk level. Then the bulk level water can be used to their family. That's no issue. Next one we can consider about that. Check, already we know. The gecko hand already mentioned how he can hold on the roof and without falling down, how he can stay on the surface. Like this, we have to consider means their finger, we can find some adhesive lamella. The adhesive lamella is combination of kind of fibrous material will be exist. This kind of fibrous material having the hydrophobic interactions of your microstructure, he can easily hold whenever he in the surfaces. So that's the reason the gecko will be stay in the roof without fall down. Most of the time we can speak about this kind of the micro array or micro lamella structures come from the van der Waals force interactions between your paint or between the wall and their hand. The similar material, they try to produce the polystyrene fibers. Then try to imitate the same material. Nowadays, the many people are try to prepare the similar mimic material with the polymer-based fibrous materials. Okay, the other one is like a slippery surface also come from the materials. The material generally come from the wax. The wax, we people considering kind of polystyrene based materials and polyamide based material. Whenever we prepare this one, the similar material can also form the waxy kind of zone, and he will be produce the slippery kind of surface in the materials. Okay. Next example I would like to show like silk proteins. The silk protein, there are two silk will be have that. Of course, silk means our Indians, most of our females, like Indian females, we are more curious in the silk. Yes, the same silk is a same property for the spider silks. Spider web, what are the silk will be there? Similar manner, whatever we use the silk, we wear the silk as a cloth, that also having the similar manner, all things. The combination of spider web and our silk, whatever we use as a fiber, like a cloth, silk saree, silk shirt, something like that. The same properties are same. All are made by the amino acids. All are made by the proteins. That protein become the polypeptide. That polypeptide become the fibrous materials. So whenever you see the one silk thread, that silk thread we can consider as some kind of skin is called like a sericin proteins. There are some core will be there that is called a silk fibrine, other one materials. The silk fibrine made by the beta sheet structures. The skin sericins called alpha helix nature. The alpha helix, when mixed with the beta crystalline nature, he can produce them beta nanocrystals will be that. The beta nanocrystals become the most strongest materials in upcoming years. You know, I remember if whatever we are going to do, there is such a similar manner with both silk and spider silks. Maybe Indian females may not don't have the chance to get the saree, silk saree, because that much uniqueness they have their materials. Even me, I publish around 5 papers about the silk proteins. I just try to exhaust the silk proteins and try to separate out the beta crystallines and alpha helix structure, and we produce like a bioimaging. We have to use like staining the biocells something, and we applied into the supercapacitor also, the same silk fibers. So that means nowadays a very good hot topic is from the nature is like from the silk materials, like silk proteins, either spider or like a normal silks. Because only thing is beautiful things, they can have the fibrous nature. The fibrous natures mainly depends upon their beta catalyst. Of course, many of us, we know amino acids can have the beta sheets, alpha helix structure, random coil structure combination together. This random coil structure, beta structure and alpha structure, everything stabilized by the hydrogen bonding. This kind of hydrogen bonding will be applicable into the all kind of application, no matter about a biological application, energy application, or environmental applications. Everywhere we can use it because of the uniqueness. The same uniqueness, just we have to try to find out the similar manner to the fibers from the silk fibers or from the spider silks. They can use the highest efficient material into the scientific field. This is some other examples. So, okay, already mentioned that we can find out from the this kind of superstructure, we can find out from the first example from the contact angles, already know. Then next one, already we know the angle of slide. That's my 5 slide before I was mentioning. Of course, we know the self-cleaning ability, already mentioned. The self-cleaning ability means the material, whenever we use to the dirt, the water molecule will be bring back the same story what I said. This is the common phenomena we can find out through the evaluate your material will be the superhydrophobic or superhydrophobic. This is why based on the self-cleaning action, somebody will be proposed a proposal is called like a lotus effect. The lotus effect means this is a key example for the self-cleaning behavior or self-cleaning ability. This kind of self-cleaning ability will be generally applicable for the oil water separations. In any field of oil water separations, the lotus effect is some key materials. Because whenever you understand the lotus effect, the same material, if you produce your materials, automatically your oil separate from your liquid. Okay. Next one is called like a collisions, elastic collisions. The same things, whenever we add water molecule here, your surface, your water molecule will be collision each other on the surface, because the surface cannot have the interaction with water, then he will be jump, and he will be run away. That means automatically your all dust will be easily removed. But hydrophobic materials, there is no way to remove it because water molecule will be rolled on the surface. This is what. So how we can fabricate? Generally, this kind of process, this kind of bio-inspired material, we can fabricate from the physical method or chemical method. Of course, we just use some kind of laser or spray or use some kind of deposition, CVD or PVD, anything, chemical vapor deposition or physical vapor deposition, anything. If you never use it, that can comply as a physical approaches. The same things. We have to use like a chemical approaches. Most of the times we can use like a chemical approaches is a very good approaches. For example, when you use a UV to activate your surface, or we have to deposit layer by layer your materials, or we have to use a hydrothermal property with the high pressure with the heating. Whenever we are heating with high pressure, it automatically can produce a biomimic materials. And the next one, we can use like a sol gel or self-assembly growth. These are the common approaches. So far, we can use the biomimicry material fabrication process. So there are many applications we have to applicable to use it. Among here, we are in my own field, I'm just using the drug delivery application and liquid separations and anti-bioadhesive. These 3 topics I'm just focusing recently from the bio-inspired materials. But today I don't want to give too many topics to you. That's why just to focus about liquid separations. That means oil, water, how we can easily separate by to produce it. These are some example. I mean, so far we are using this variable nanomaterial and variable property of variable method we exist with the materials, right? So I would like to take 5 more minutes to introduce some of my research with bio-inspired, similar like a fish. You know, like whenever we put the fish into the water, the fish, the skin cannot be attached to any water. It can be easily moved. That means it's called a super oleophobic. This another one more topic will be exist. That means if we produce such a material to produce a oil water separation, that means it will be good for us. That's why one study I just try to exploring about the bio-inspired, just like a fish kind of skin. We want to produce a fish kind of skin, we have to use it through the biopolymer. This kind of polymer is called a carginen. The carginen will be have the sulfate group in the surface. There was one more carboxyl group on the surface, and there are many OH group there. This is the carginen materials. There is one clay. The clay, clay means like layered clay, nanomaterials clay. This is a nano-size clay. The clay having many atomic layers, just mixing together via intermolecular interactions on the polyacrylonitrile membrane. Just got this negative ions, the carboxylic ion have the carboxylate ion have negative. The negative will be attached to the positive. Then the positive attached in the sulfate negative ions. That means we are using different layer prepared as a layer by layer materials. That materials I try to use the oil water separations or remove the metal ions or remove some dyes. So this is what before the modification, the surface like this, the porosity will be there. After modifications, the porous automatically will be vanished. Of course, the multi-layer we evaluate from the variable method. The one more, of course, FTIR we know or PAX we know, but I don't know how many people know about Raman mapping. 3D Raman mapping is one of the good tools. I am happy to introduce you this one because as I remember, there are many countries that does not have this kind of facility. The facility can be applicable just to select one particular part, a particular peak of the Raman spectra. Then we have to scan. It's like a SEM image. He can scan how much or how many quantity of your that particular peak, particular functional groups exist on your material. It can be easy way, the easily visualization for understand your compositions. That's why we are using like a 3D Raman mapping to evaluate how the layer will be forming. This is whenever we calculate the carginen is a top, this other one is a lower. That means we understand that different color is a different layer is existing. So simple examples. So this all material having around 160 degree of water contact angles. Then how much the flexing. These are the how fast we are flexing. The flex means how fast he can separate out. These are the informations. This example, the self-cleaning ability or anti-oil fueling ability is kind of the, as I mentioned, like a fish imitating materials. Whenever we use the oil in your materials and your material, the oil does not exist or does not attach to any outer traces when put it in the water molecules. So that's what we are analysis by the self-cleaning ability. This is a one material. Of course, this will be produced effective separation process of your oil mixed emulsions become the clear solutions. The same material we applied for the dye separations. The rhodamine B used and beryllium blue we are using. The all will be easily separate out without any traces amount. Okay, then up to 500 ppm it was ready to separate it. Same times we use some kind of metal particles like lithium, sodium, potassium, anything. So everything we separate out, and similarly one more like a special wettable material, same continent, other polymer material, we are just to produce. Same with the graphene oxide as a co-materials. Again, the same interesting is the distributions evaluate from the 3D Raman mapping. The same oil water separation and self-cleaning properties we observed how the water molecules will be exist on the surface. These are the material, almost a similar material, only the material is the same. Materials are different, but application is almost same. But one more thing is the last study, this one. Most of the times I use like a hydrophilic material, super hydrophilic material. These times I try to use like a useful materials like a melamine sponge. You know, like melamine sponge, whenever we have our home, we use the dishwash. The sponge is called a melamine sponge. Because melamine sponge, I want to use as a useful manner. That's why I just incorporate with the polycaprolactam, lactic acid as a absorbent for the oil. Whenever we oil fall down, the carbo PCl and PLLA will be absorbed all materials from the oil and he can exert in the surfaces. So these are observed melamine based modified material we applied into the remove the all oil water separations. You know, whenever we speak about this kind of material, the porosity is the most important. That's why the porosity we found out from the uniform like a honeycomb like structure. The honeycomb like structure means the honeycomb, the uniform surface how it exists in similar manner. It also will be we produce as a bio-inspired material. Then this kind of material we apply for the remove the oil from the water contaminations. So all oil easily can be removed and from the water mixer. These are the some dye mixer water molecules, how he can observe, how he can release. These are the property we use it. Finally, I'd like to say the similar material, we try to use the self-assembly process. Cationic polymer and anionic polymer just mixing together, we have made like a polyelectrolyte complex. The polyelectrolyte complex we produce, that complex we produce as a self-assembly way as a like a kind of microparticles. You know, to microparticles. This kind of microparticle we used to use the dye, emulsion, water, everything we want to separate. That's why we have to use like a underwater this one. That everything will be show around 152 degrees, something like that means very good material for the wetting property. This property we apply into the Stola stream generations. The Stola stream generation means this is a taking the sea water become normal water, something like that. We have some concept, right? The same concept we are trying to use it. That means using the solar steam we have to generate. That generation stream we have to collect as a purified water. This kind of approaches we use to the same self-assembly materials. The self-assembly material that can have them both positive charge, I mean sulfate groups and amine groups, quaternary amine groups. This kind of amine groups, sulfate groups, can have the possibility to consume the salt ions. For example, if you are material having the sodium chloride or potassium chloride or some other any like a sea imitating salt, this kind of salt material can water when we put our materials there. Then automatically your sun will be heat. The heat will be photothermal effect will be induced. The photothermal effect will be the photothermal effect will be heat the bottom of the water and he generate the pure water. The pure water will be collected in almost like 3 liter almost we are collecting from 3 hours, something like that way. So the photothermal effect will be the other important things in these studies. So everything we can produce via bio-inspired way. That's why the bio-inspired way, there are many materials we produce to force the environment protection applications. This kind of environment protection applications will be used to for us. Okay, these are the some reference. There's most of them from my paper only. Maybe you can check my name and then you can get it there. And I would like to express my intention in the last slide. The last slide can be give the intentions. That means we can learn everything from the nature for our modern research, but we should not be destroy our planet. We must be save our planet. And thank you for your patience. Sorry, I took almost 20 minutes extra, and this is a question times. And before that, I would like to inform Taiwan is one of the best, beautiful country. The name itself, the Queen of Island. That means this is the most, wherever you can see the greenery only there. The development also will be there. The nature also will be there. Both traditions and development combination countries like Taiwan. So I would like to welcome everyone to be there, visit Taiwan at least once a life. If you have any questions, please. Divya?
Yes, sir.
I am finished.
Yes, thank you. It's a very nice, interesting
I
session.
could turn on my camera.
Yes. Hi. Yes, if you have any questions, you can post in the chat box.
Hope you could get some idea, right?
Yes, it's very interesting.
I have a question.
Yes, ma'am.
As you said, hydrophobicity increases when the roughness is high.
Yes.
If it is so, we can say like this, no, sir. When the surface area increases, automatically your hydrophobicity increases. In turn, it will hold the water particle over its surface. Like that, we may say, or any controversy over this statement?
Yes, ma'am. This is just a controversy must be there because the hydrophobicity is a direct relationship to the surface energy. Surface energy, wherever it's low, then only hydrophobicity will be higher. So surface energy, if you want to increase, means automatically your hydrophobicity will be decline.
Okay, sir. In no way it is related to your surface area.
Yes. Surface area, we not able to keep about surface area because surface area, there is not influence in your property of applications. Surface energy is the most important than surface area. Because surface area, how much we are going to be used, that's only will be giving the information to us. Unfortunately, whether we are going to be filter or we are going to be fabricate the big amount or small amount, no matter about that. How the molecule will be oriented, how molecule is arranged in your materials, that will be giving the clear idea. The orientation or arrangement or alignment will be given the responsibility for the energy, surface energy. So,
okay, sir. Okay, sir. Okay, sir. I understood. And one more question is this, sir.
Yes.
Sir, we have so many hydrophobic materials. Now you told us about super hydrophobic material. Shall we use these type of materials for oil removal applications from water, ocean water, or from sea water?
Yes, yes.
Can we able to remove this because it is a very tedious process? Also, it is not cost effective nowadays. Can we able to recollect the oil spill from the
Yes,
water source by using this super hydrophobic material. Is it cost effective? Is it possible, sir?
yes, ma'am. This is very easy. But the thing is, whenever you can consider like a hydrophobicity, the oil also will be more hydrophobicity. Hydrophobicity. Once you collect the water means how you have to remove the material from the absorbent. That's a problem. For example, my study, I mentioned like a absorbent material, melamine sponge. I just prepare the melamine sponge with the polymer coated. This is a super hydrophobicity. Okay, fine. I used the water removal because last 4 years before I remember, Chennai port have some big accident, raw oil accident. That time I saw that one. I was thinking that one, how I can remove this kind of things. That's why I just planning similar manner, like bulk level. Like that's why we prepare like layer by layer materials. Same times hydrophilic material, hydrophobic material. Both I can try to think it. Super hydrophilic material is more effective than super hydrophobic materials. Why means super hydrophobic material, for example, melamine sponge already prepared. I removed oil from the water mixer, no problem. 100% oil we can remove. From here, how we have to remove? From sponge. For example, we already super hydrophobic prepared, removed, you have removed all water molecules, all oil molecules, no problem. From the material, we have to isolate, right? We have to separate out the pure oil separately. Your absorbent material is separately, should not be mingled each other. But in the case of hydrophilicity material, if you bring the material towards the oil, then automatically oil molecule will be coming one places. Then you can remove the places. So my aspect of view, if you are considered about super hydrophobic materials is more better than super hydrophobic materials. Why? The first of all, the abundance, easily available. If you are taking any polysaccharide materials, is good. Most of the polysaccharide material, naturally available polysaccharide material, are hydrophilic nature. They're also having super hydrophilic nature. If you are going to be used like a hydrophobic material, it is really tedious process. That means we have to produce only silicon polymer, or alkaline material must be there. Alkyl group must be there. How much you are increase the alkaline group, that much level we have to use that one. That's why whenever you are speaking about super hydrophobic materials, we always considering, or we always thinking, most of times like a PDMS polymer or silicon based polymer or alkaline based polymer, this kind of things only, aromatic polymer, these are the only, they will be countable. That limited amount of polymer will be there. The raw material also will be quite expensive. And but we have many options. We can do the many versatile research in the super hydrophobic materials. As I mentioned, like directional orientations, like water collections, anti-fogging window. There are many things in the membrane science we can do it. Hope you got it, my answer, right?
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir. That's all, sir.
Okay, thank you, ma'am.
Thank you very much, sir.
Thank you, sir. We are extremely thankful to you for a gracious presence as well as an interesting and very informative presentation. In spite of your busy schedule, thank you for allocating a time for us. This shows a reflection towards commitment towards work. Thank you once again.
Thank you, Divya. Thank you everyone for your opportunity
on behalf of the management, I
introduce
thank
my
you.
work.
Now I request the participant to fill the feedback form, which is shown in the chat box. I request you to be here as the I would like to invite Dr. M. Rajeshwari to give the report on conference, and one more information to all participants. You have one more feedback form after finishing this valedictory function. Thank you.
Good evening
Thank
to
you
one
very
and all. I take this opportunity to consolidate the report for the 2 days International Virtual Conference. IQSC and the Department of Chemistry, Annai Violet Arts and Science College organized an international virtual conference on chemical sciences on 8th and 9th of February 2022. The conference was started with a prayer song by the college choir. Our college principal, Dr. C. Inita Lebanon Ebensi, gave the inaugural address, and Dr. L. Parimala, Head Department of Chemistry, welcomed the gathering and briefed about the conference and the department. Session 1 started at 10:45 a.m. and was presented by Dr. S. Agnes Mary, Young Scientist Fellow, Department of Health Research, Central Leather Research Institute, Chennai. She explained about the techniques and applications of polymeric hemodialysis membrane for renal diseases. Session 2 started at 2 p.m. and was presented by the guest speaker, Dr. N. Rajendran, Associate Professor, Department of Polymer Science, University of Madras, Chennai, on the topic Recent Developments on Synthesis of Macromolecules, Stabilized Noble Metal Nanostructures, and their chemical and biological applications. He briefed about the noble metal nanostructures, preparation, properties, and their applications. With these two sessions, the first day of the International Virtual Conference ended successfully. On 9th February, session 3 of the International Conference started at 10 a.m. The guest speaker, Dr. Kamaraj Sathu, Assistant Professor, Department of Biotechnology, Periyar University, PG Extension Center, Dharmaburi, delivered his lecture on the topic polyphenols and their effects on enzyme inhibition, a solution for serious diseases. He gave brief note on the properties and its action as drug to treat various diseases. At 2 p.m., session 4 was presented by Dr. T. Ilakia, Assistant Professor, PG and Research Department of Chemistry, IIC and ARIIA Coordinator, Innovation Ambassador, Sri Sarada College of Women, Salem, on the topic Electrospun Nanofibers Membrane for Water Purification Treatment. She briefed about the preparation of nanofibers membrane to be utilized for water purification technique. Session 5 was presented by Dr. A.K. Prasannan, Assistant Professor, Department of Material Science and Engineering, National Taiwan University of Science and Technology, Taiwan. At 4:30 p.m. on the topic Recent Trends in Bio-inspired Nanomaterials. He explained about the preparation of various biomaterials that has been utilized for various biological applications. Feedback was received from all the participants for all the session to upgrade the standard of the forthcoming events. All the sessions were highly informative and interactive. At the end of the virtual program, the aim of the conference was fulfilled, and we hope that the participants receive intelligent insights from all the guest speakers who all are the leading professionals. Surely, it could be a stimulating factor for personal as well as professional growth for the students and the young researchers. In addition to the guest lecture, we received 2 international, 26 national abstracts and 7 e-posters from various institutions from India and abroad. All the posters were acknowledged and selected were allowed to present through the Zoom platform, and the best poster were honored. We are happy to share with you all that we have crossed 820 views through Zoom, through YouTube. Hence, we conclude that the International Virtual Conferences on Chemical Sciences was a grand success.
Divya ma'am, unmuted.
Thank you, Dr. M. Rajeshwari. Now, I request Dr. L. Parimala to announce the winners of poster presentation and oral presentation, and to render a vote of thanks.
Ma'am, unmute. Parimla, ma'am, unmute.
Happy evening, everyone. We have come to the end of the program. It is time to announce prize winners. Best Presentation Award goes to Muthuraja, School of Electronics Engineering, VIT, Vellore. And Best Poster goes to Sindhuja, PG and Department of Chemistry, Sri Parama Kalyani College, Tenkasi. And third place goes to Kuldeep Singh, Dr. Kuldeep Singh, Department of Chemistry, Amity University, Madhya Pradesh, Gwalior. Third prize is shared by Dr. Nadia, Annai Violet Arts and Science College, Chennai. Second place goes to Dr. B.Y. Bahal, Vasantrao Nayak Arts, Commerce and Science College, Shahada, Maharashtra, India. First place goes to Dr. John Bosco, Esuraj, Department of Mechanical Engineering, Chubu National University, South Korea. And some participants have shared their video link on feedback. Just I want to share it. Can you able to see my screen? Hello, can you able to see my screen?
Ma'am, your screen is shared, but your video is not shared. Just wait for a few seconds, ma'am.
I cannot able to open this.
Just stop the screen and reshare it again, ma'am.
Stop page.
Try to open the video first and then share again, ma'am.
Okay. So can you see?
No, ma'am, only that black screen is there. Just wait for a second. No, ma'am, it's not sharing. Yes, now it's shared, ma'am. You just play that video, ma'am. Ma'am, you are not shared that audio, ma'am. Just pause that video. Just go to the top. A menu will be there. 3 dots will be there. Click that and share. Click share sound, ma'am.
Yes, I found.
Part of your conference, and you provided me the space for me to explore my research, and the arrangements that you made was really awesome. And particularly in this pandemic situation, even if you try to conduct this conference online, all the possible smart things that you handle, like the social media, WhatsApp, and other platform like YouTube and all, was really supportive, and the way how you handled was really awesome. And I just want to extend my sincere thanks and also my support for your future endeavors, and really good. It's a good job. It's a teamwork, I know. Really awesome. And definitely, I hope your students will also be getting benefited more by this kind of activities. Thank you so much.
Good afternoon to all of you. Myself, Dr. Rita Vasi, Associate Professor, Department of Chemistry, Brahmanand College, Kanpur. It was a great pleasure to attend and be a part of this international virtual conference on chemical sciences organized by Department of Chemistry, Anai Wallet Science and Art College. I congratulate the organizing committee for their efforts in organizing this program in a systematic manner so as to make this program a great success. I would also like to thank the eminent speakers for their excellent, clear and vibrant presentations, which has really helped us to gain knowledge. Their in-depth knowledge has indeed been extremely helpful to all of us. Thanks a lot.
Good morning all. Myself Dr. Deepti Shikhar, Associate Professor, Department of Chemistry, Brahmanand College, Kanpur. First of all, I would like to congratulate to organizing team of this international virtual conference on chemical sciences for organizing this wonderful webinar. I would like to thank all the resource person for giving their valuable information regarding different topics. I really enjoyed my time at the conference. I am impressed with the commitment and efficiency of those who planned this conference. Thank you.
Thank you for giving us feedback. It's now time to propose vote of thanks. So gratitude is the healthiest of all emotions. On behalf of the Department of Chemistry, Anai Violet Arts and Science College, it's my pleasure to propose vote of thanks for the successful completion of the International Virtual Conference of Chemical Sciences held on 8th and 9th February 2022. First and foremost, I would like to render our very special thanks to our most respected chairman, Chevalier Dr. N.R. Dhanapalan, our dynamic secretary, N.R.D. Prem Kumar, our mentor and joint secretary, Dr. Prem Chand, for their constant encouragement and providing a stimulating environment to organize the conference. I feel happy to offer our heartfelt thanks to beloved principal, Dr. Inita Lebanon Evansi, and Vice Principal, Mrs. Jafia Solomon, for their encouragement and guidance towards this event. My sincere thanks to invited speakers, Dr. S. Agnes Mary, Young Scientist Fellow, Department of Health Research, Central Leather Research Institute, Chennai, Dr. N. Rajendran, Associate Professor, Department of Polymer Science, University of Madras, Gindi Campus, Chennai, Dr. Kamraj Shatu, Assistant Professor, Department of Biotechnology, Periyar University, PG Extension Center, Dharmaburi, Dr. T. Ilakia, Assistant Professor, PG and Research Department of Chemistry, Sri Sarada College of Women, Salem, Dr. A. Prasannan, Assistant Professor, Department of Material Science and Engineering, Taiwan, who have readily accepted our invitation, enlightened the sessions with thoughtful lectures. I hope the aim of the conference has been accomplished and is reflected from the response of the abstract received. It is my duty to convey my thanks to Dr. A. Chandramohan, Head Department of Biochemistry, and Dr. Hamsavadani for chairing the presentation sessions. My heartfelt thanks to the organizing team, Dr. Dairya Lakshmi, Dr. Rajeshwari, and Mrs. Divya for their untiring effort to bring this event successful. I thank Dr. Prabharan, Head Department of Physics, and Dr. John Rodney for their active interaction during the presentation sessions. I am delighted to thank all the participants and presenters across the country and outside the country, because of whom the conference have reached this level. I am happy to express my sincere thanks to our technical team, Mr. Yonesh, Head Department of Business Administration, Mr. Abhilash and Mr. Loganathan for their support, timely help and cooperation. Once again, thank you all very much. Thank you.
Thank you, ma'am. We have come to the end of the session and the conference. Now let's all stand up for national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे